We're going to talk about jets versus props or thrust versus power. So the differences between jets and props and thrust and powers. We're going to group airplanes into two big groups. One, they're going to be thrust producers or power producers. We're going to call jets thrust producers because they transform fuel directly into thrust. We're going to call propeller-driven airplanes power producers because they transform fuel into power, and then through a propeller, then they turn power into thrust. Thrust is going to be the force, one of the four forces, so the force that is really propelling us, even though in the case of props, they turn fuel into power first, and through the prop, that's transformed into thrust. So jets are going to be jet-powered airplanes. Props can be either turboprops or reciprocating engines that have a prop. So and then we're going to have different types of thrust and power. Thrust available, thrust required, power available, and power required. So in this case, we're going to draw the thrust versus velocity curve. So on the y-axis, we're going to have thrust and also drag. And then on the x-axis, we're going to have velocity. So the first type of thrust that we're going to talk about is known as thrust required. And the thrust required is, if you look at this graph, the thrust required curve looks the same as something we just studied, and that is drag. So thrust required is the same as drag. And the meaning of thrust required is that thrust required is the minimum amount of thrust required to overcome drag to maintain level flight at a different airspeed. So you see, if you go slow, you're going to need more thrust required, and as you speed up, you're going to need less until you get to the minimum point, and then you're going to need some more thrust required. So thrust required really has nothing to do with the engine on the airplane. It has to do with the amount of drag produced by the airplane. So a glider has a thrust required curve. Why? Because thrust required is the same as drag. So we said that jets are thrust producers because they transform fuel into thrust, meaning that the thrust available or the thrust output for jets is going to be constant. So we're going to draw the thrust available for jets, and it's going to be roughly constant, so roughly a straight line. So this is thrust available for jets and is constant. So it's a straight line. So we have thrust required, that is the same as drag, and thrust available, and it's going to be constant for jets. That's why we say that jets are thrust producers. Now let's talk about power. So power, we're going to draw it. Power is going to be thrust times velocity, and we'll derive this equation in class. So power is thrust times velocity. So it's not, power is not equals to thrust. Power is thrust times velocity. And we're going to, again, have different types of thrust, different thrust types of power. We're going to have thrust available and thrust required. Thrust required is the same as drag. Thrust available is going to be the thrust output. And we're going to have power available and power required. So power required is going to be thrust times velocity, or thrust required times velocity, that is the same as drag times velocity. And power available is going to be thrust available times velocity. So if we're talking about props and we're drawing power, thrust, and drag on the y-axis and then velocity on the x-axis, we'll draw first thrust required, and thrust required is the same as drag. And this is for my prop. And it doesn't matter whether it's a prop or a jet, because thrust required the same as drag. So it doesn't matter, it doesn't have nothing to do with the engine that is on it. It just has to do with the drag. Now, to draw power required, we're going to do thrust required times velocity, and we're going to draw power required. And power required, this is going to be power required, is going to be very similar in shape than drag, or thrust required. It's just a little narrower and a little higher, because it's going to be thrust required times velocity is the same as drag times velocity. And there's going to be a unit conversion number of 325 to convert, get power in horsepower, thrust in pounds, and velocity in knots. So it's going to be power required is drag times velocity over 325. This is a unit conversion number. And so if I take, let's say, this value of velocity here and multiply it times my value of drag or thrust required, divided by 325, that's going to give me a value, and then I'm going to draw that. And then I'm going to do the same for the different other points, and then I get this curve that I drew in this light blue here, and that's going to be power required. Now, for power available for props, we said that power available is relatively constant for props, because props are power producers. They transform fuel into power. So now if I want to draw power available for props, power available for props is going to be constant. Okay, let me let's do it in red actually, because we can see it better. So power available for props is going to be constant. Okay, very good. So now let's draw power available for jets. So let's talk about power for jets. So we usually talk about jets in terms of thrust, but we can interchange power or convert power to thrust or thrust or to power via this equation. Power is thrust times velocity. Okay, so again, if we have here power, thrust, drag, and x-axis is velocity, and we have, this is the drag curve, or the thrust required curve, thrust required equals drag. Now we're going to draw again power required. Power required is thrust required times velocity. So it's going to look like something like this. And now we're going to draw power available for jets. So power available is going to be thrust available times velocity. Now we know that for jets, thrust available is constant. So we have that power available is a constant times velocity. So how would that look like if we drew it? Power available is a constant times velocity. So it's like saying y equals b times x, something like this. So that's going to be a straight line going up, something like this. So this is going to be power available for jets, and this is for jets. It's going to be a constant times velocity. So what does that mean? That means that my power available, if I'm in a jet, is going to increase linearly with velocity. So as my velocity increases, my power available increases. For my jet, we saw that my thrust available is going to be constant with velocity. Now let's take a look and see what happens to props. So now I'm going to draw thrust, drag, velocity for props. So the first one I'm going to draw is thrust required, that is the same as drag. So it's going to be the same curve if I have the same airframe. And now let's do power available, thrust available for jets, thrust available for props. Thrust available for props. So it's going to be what? We know that power available is thrust available times velocity. We know that for props, power available is constant. So we're going to solve out of this equation for thrust available. So thrust available is power available over velocity. We know that for props, power available is constant. So we have that for props, thrust available is a constant over velocity. It's going to be power available for props. So what does that look like? It's like saying y equals b over x. So what does that look like? That's going to be a descending line, a line going down, and this is going to be thrust available for props. So look at that contrast. That means that the faster I go, my thrust is going to be lower. Now remember, the four forces are going to be thrust, drag, lift, and weight. So thrust is the force that moves us forward. And the faster I go, the lower my thrust is going to be. So that's something that is going to be a huge problem. Why is that? Because propellers, because they have a propeller, the faster it goes, the tips are going to start going supersonic. And if it starts going supersonic first, when it starts going supersonic, there's going to be a shock wave, lots of separation, lots of drag due to the tips going supersonic of the prop. So because of that, is not going to be able to go any faster. So one huge revelation by looking at these graphs is that you're not going to be able to go supersonic in a prop-driven airplane. And that's the reason why you see any airplane that goes supersonic has a jet engine and not a prop engine. So that is a big revelation. So please review this. This is kind of in a nutshell the differences between props and jets.